Hello everyone. In this video, I am going to explain one of the application layer protocols of IoT protocol stack that is MQTT. MQTT stands for Message Queuing Telemetry Transport, which is a lightweight protocol. What do you mean by lightweight protocol? Here, the message packets have less number of fields, as well as the size of the message packets are small when it is compared to other protocols such as HTTP, HTTPS. So that is why it is called as a lightweight protocol, and it is a publish subscribe network protocol that transports the messages between devices. And this is the protocol which is standardized by organization, that is OSS. It stands for Organization for Advancement of Structured Information Standards, and this application layer protocol runs over TCP IP, and this is a protocol that is particularly meant for constrained nodes and constrained network. And this is the protocol that is based on client server framework and publish subscribe framework. Here this protocol, it defines two entities. The entities are server and the client. MQTT server, it is also called as a broker, and MQTT client, which can be either publisher or it can be subscriber. Here the entity that is called as a client or a publisher, it sends a message to the broker, and this broker, it receives the message and routes to the subscriber, that is a particular client that has subscribed this message. For example, in this diagram, if you see here, we have a sensor, okay, that is a temperature sensor, and as well as a relative humidity sensor. We call this as a publisher. It sends this data, that is a message containing temperature and relative humidity to the broker, and this broker routes this message to the client that have requested, that have subscribed this message. So here this is nothing but a publish and a subscribe frame, that is the framework which is used by this MQTT. And this MQTT here, in this framework, these publishers and subscribers, they do not know each other. Publisher just keeps sending the messages, and it will not be knowing which all clients have subscribed this message, and subscribers will not have any idea about which client have published this message. And this message broker, or it is also called as a server, it also buffers the message that are transmitted by this publisher and cached in case if there is a network failure, and it also handles subscription and unsubscription process. This we will consider now how this subscription and unsubscription is carried out. Now we will consider about the message format that is used by these clients as well as server. These are the different fields of message, MQTT message. Here we have a header which is of 2 bytes, header of 2 bytes. This is first byte, upper one. Next one is second byte. The first byte has the field, first field, that is the message type, indicates which message. There are totally 14 messages are there. You can see here there are different 14 messages are there, and these are numbered from 1 to 14, and this will be stored in this field, that is a message type. Okay, now the values 0 and 15, they are reserved, and we have one more field, that is DUP. This DUP is the flag, okay, which when set, it indicates that the receiver has received a duplicate message. It has been resent from the sender if the receiver has not acknowledged. Then we have one more field, that is quality of service, that we are going to consider next. Then we have one more field, that is retain, and this is a flag which is found only in the publish message. When it is set, the server holds that message. That is why it is hold in the server. If there is any new subscriber, then it doesn't have to wait for the next message. It can receive this message until it obtains the next message from the that is a publisher. Okay, so these are the fields in the first byte. Then we have one more field in the second byte, that is a remaining length, that indicates the next fields. Here we have this variable header field that you find in some of the message packets. Then we have this payload that contains the data to be transmitted either between publisher and server and the subscriber. Next, here this slide shows the messages that are communicated, that are transferred in between the client that is called as a publisher and the server. If there is a message to be transmitted between publisher and the server, then publisher has to connect first. Then in that case, it can make use of these messages, connect and acknowledgement. That is to request to connect to the server, and server can acknowledge that. Then once it is connected, then it can make use of this publish message that contains the data to be transmitted to the broker, and this can be acknowledged. Then we have other messages that is to be transmitted between broker and the client, that is called as a subscriber. Again here it has to be connected. In that case, it can make use of these messages, that is connect and connect acknowledge. And once it is connected, then the subscriber can subscribe using these message, that is subscribe, and it can be acknowledged. If in case if it doesn't want to subscribe, it can unsubscribe using this unsubscribe and acknowledge. Okay, then it can get disconnected by using this disconnect message. Then we have two more message that are called as that is ping request and ping response, which are used to validate the connections between client and server. So these are the different messages that can be used by these clients and server. Here one field that we are going to now consider about, that is the QoS, stands for quality of service. That indicates to what extent, to what level the message can be delivered at the destination. So here there are three levels, that is a QoS of three levels. If it is a zero, the publisher, that is you can if we consider this publisher and the broker, in this, if this QoS is set to 0, publisher sends the message. And here once it is sent, then receiver need not to acknowledge that. No response is sent by the receiver. Similarly, if QoS is set to 0 in between this broker and a client, that is called as a subscriber, then if server sends a message to the subscriber where QoS is set to 0, then the server need not to be acknowledged. No response is sent by the receiver. Okay, so that is what happens when QoS is set to 0. Then we have one more QoS level, that is 1. Here, using this level, we can ensure that the message is delivered at least once between that is sender and the receiver. Here, if you consider now between the data message transfer between a publisher and the that is a server, and if QoS is set to 1, here if the message is sent and if the server has not responded, the client again resends that. So that is what happens if QoS is maintained at level 1. Okay, so that is what about the QoS 1. We have one more level here. If this level is set to 1, then we can ensure that there is no loss of a message, or there is no loss of message, as well as there is no duplication of a message. If you consider the message transfer between the publisher and the server, and if QoS is set to 1, then confirming the receipt of the message at the server, it can be ensured in 2 steps. In the first step, these 2 messages are used, that is publish and publish receive packet pair between client, that is a publisher, and the broker, and one more pair, that is publish release, publish complete. Another packet pair is used in between this publisher and the broker. So here this message delivery at the recipient can be ensured at least once. So these are again explained here. When this QoS is set to 0, and if you consider the message transmission between publisher and the server, okay, so at most once delivery, here at least once delivery, and exactly once delivery. So this is about the levels of use of these QoS levels. Coming to this last that is about MQTT, we have as a MQTT topic. Here, as I explained, if you consider this MQTT application layer protocol, we have clients that are called as a publisher, as well as we have clients that are called as a subscriber. Here the messages, okay, that is published by the publisher, okay, we say that the publisher publishes the message, and here we say that subscriber subscribes a message, and these messages, all these messages belong to a topic. Okay, all these messages may be subscribed or may be published. These messages, they come under a topic, they belong to a topic that is maintained at the server, and these topic, they have the hierarchical level. Okay, they are maintained in a hierarchy at server. This is similar to what we maintain in our system, the files and folders. In our system, That is in our computer system, we maintain files and folders, files and folders in a hierarchy. If you consider here one example, we can have a document. Under this we can have a folder. Under this we can have one more folder, and under this we have one that is a file, q3 sales.ppt. Similarly, the messages that are published as well as the subscribed, they will be under a topic. They will be they will belong to a particular topic. They will be maintained under a topic, and those topics will be at a server, and those topics will be maintained in a hierarchy. So one example, if you consider, suppose you consider a building that has the temperature sensors, that has temperature sensors which are maintained at different floors. Okay, so you consider that in that building we have a ground floor, we have a first floor, and in the ground floor we have two rooms, and in the first floor also we have two rooms. In each of these floors, in each of these rooms we have a temperature sensor. And if these temperature sensors, if they publish the message containing the temperature, then we can set up these topics, these four topics. That is, under the building, under the ground floor, under the living room, we can have a topic, that is temperature. So temperature sensor in the first that is in the ground floor in the living room can send a message, and that will be maintained as this first topic at a server. So this is what is the topic. So publisher publish a message, and it will be belonging to a particular topic. So these topics, they have different levels. We say as these as the topic levels. This complete is topic name, and this will have different topic levels. Okay, so now a publisher can publish a message that will be of a particular topic. Now that is about a publisher. Now how about the subscriber? The subscriber can subscribe one or more topics. If a subscriber subscribes one topic, okay, that is, if a subscriber wants a message of one topic, then it will make use of such type of a topic name. A subscriber can also subscribe multiple topics. That is, for example, if you consider this subscriber, single subscriber, if it wants temperature values of multiple publishers, publisher 1, publisher 2, publisher 3, if it wants temperature values of multiple publishers, then it can subscribe. Okay, in that case, how it can subscribe multiple topics? In that case, it has to make use of the wildcard characters, special characters, hash and plus. This hash, okay, we'll start with the plus. Plus, if it is used in the topic name, then it indicates one topic level. Say, for example, if a subscriber has used this topic name containing plus, then it indicates one topic level. Okay, so it can subscribe these two topics, that is, under the building, under the ground floor, living room, under the building, under the ground floor, kitchen. So it can subscribe two topics. It can receive two temperature values of the ground floor of the building. So that is what is indicated by this plus. You can also have one more wildcard character, that is a hash. Hash indicates multiple topic levels, not single topic level, multiple topic levels. For example, if client has used this topic name, then hash indicates these different um, topic levels. One topic level, another topic level, one, two topic level, two topic levels, two topic levels. So it can receive temperature values from 4 temperature sensors. So that is what is the use of this hash in the topic name that is used by the subscriber. Okay, so now coming to this last, that is about the difference between MQTT and COAP, so that you make a self study. Thank you.